Assalamualaikum warahmatullahi wabarakatuh and a very good day to my Honorable PECIPTA 2022 judges. Today I'm going to talk about my invention with the title of Carbon Capture by Eggshell Waste. My name is Associate Professor Dr. Midhat Nabil bin Ahmad Salimi from the Faculty of Chemical Engineering and Technology, University Malaysia Perlis, UniMAP. This research project is also a collaboration with Teknologi Tenaga Perlis Consortium Sedia Berhad or TTPC. It is also fully funded by the 2021 FRGS grant with the title of The Interaction Mechanism of Eggshell Waste as Solid Sorbents for High Temperature Carbon Dioxide CO2 Capture. So I would like to start with the problem statement of my research, which is global warming. Global warming can be defined as the rising of global average temperatures. Some of the effects of global warming include less snow and ice, more droughts and wildfires, warmer oceans, and rising sea level. Carbon dioxide's invisibility is what causes global warming, meaning that the more CO2 gas is emitted, the more of this gas will trap heat, leading to global warming. In 2017, the transportation sector had contributed the most amount of CO2 emission, which was 47%. This was followed by the industrial sector, which contributed another 23%. In terms of largest producers of CO2 emissions worldwide in 2017, China led the list, followed by US, India, and Russia. Basically, the larger the country and with higher population tended to produce more CO2 emission from the activities to support the population. Shockingly, Malaysia was ranked at number 26 as the largest source of greenhouse gases in the world. Naturally, the emitted CO2 will be captured 25% by trees and forestation, and another 25% will be captured by the seas and oceans. The remaining 50% of the emitted CO2 will be remain in the atmosphere. My invention is based on eggshell or ES waste. Eggshell or ES is an emerging abundant solid waste created from various sources such as poultry, homes, restaurants, and food manufacturing industry. In Malaysia, about 642,600 tons of eggs are produced every year, and from this amount, a total of about 70,686 tons of ES waste is expected to be generated every year. This waste has potential for producing hydroxyapatite with the chemical formula of Ca10PO4,6OH2, a major component found in bone and teeth. Hydroxyapatite has the big potential application for carbon capture. It is well known that carbonate ions can substitute into the hydroxyapatite lattice by replacing both phosphate and hydroxy groups. The image at the bottom showing the phosphate and hydroxy groups within the hydroxyapatite structure. For my invention, the first step for the process is to synthesis of hydroxyapatite from eggshell waste. This is done by the mechanochemical method by using a planetary ball mill mixed with dicalcium phosphate dihydrous. The image at the bottom shows the produced hydroxyapatite powder. Secondly is the process of converting the HAP particles into solid sorbents. This is done via using a wet-based granulation process. The image shows the hydroxyapatite granules or solid sorbents with dimensions of a length of 3 cm, diameter of 0.5 cm, and a weight of 1 gram. And lastly, for the carbon dioxide CO2 capture analysis, carbonation was performed in a tube furnace under a dry CO2 flow. The amount of CO2 absorbed was done by comparing the IR adsorbents of the released CO2 against a calibration curve. The image at the bottom shows the tube furnace used. As a result, hydroxyapatite granules absorb almost 8 times its weight in carbon dioxide or CO2. Carbonate was substituted into two ionic sites of the hydroxyapatite structure, one at the phosphate sites and the other one at the hydroxy sites. The image shows where the CO2 absorbs into the two locations within the hydroxyapatite structure. In terms of novelty, this was the first reported of hydroxyapatite nanoparticles synthesis with control parameters by mechanochemical method which produce uniform and small particle size. It has a patent filing with the patent filing number of PI 2014702579. In terms of publication, I had published in some reputable journals such as Powder Technology, which is a Q1 journal with impact factor of 5.64. I also had published in Materials and Chemistry and Physics, which is a Q2 journal with impact factor of 4.78. As I mentioned before, I have an industrial collaboration, which is Technology Tenaga Perlis Konsortium Sdn Bhd or TTPC, which had expressed their interest for research collaboration in terms of the applicability of the hydroxyapatite granules in absorbing carbon dioxide CO2 produced at the power plant facility. This means to test the hydroxyapatite granules in a larger scale environment. In terms of commercialization, the carbon capture and sequestration market was valued at 4.4 billion USD in 2018 and is expected to reach 14.2 billion US dollar by the year 2025. For the product status, it is now at technology readiness level TRL7, which is system prototype demonstration in operational environment. For conclusions, Eggshell or ES is a natural waste produced in abundance yearly, which can be transformed into hydroxyapatite granules for carbon dioxide CO2 capture application. This avoids of using synthetic chemical formulations to capture carbon dioxide, which are less effective and costly. Hence, this invention is also can be considered as green invention. This innovation also supports the Sustainable Development Goals SDGs under Goal 13 climate action. Eggshell is a waste largely considered as useless and is discarded, which contributes to environmental pollution. In fact, eggshell waste can be used for carbon capture and its impact is huge globally for tackling the global warming issue in many years to come. So that's all for my presentation. I hope you all have a great day and thank you for spending your time listening to my presentation.